Okay, let's cover the review for exam one. Given the points on a graph, answer with ordered pairs. So A is at 2, -5. B is at 4, 0. C is at -4, -5. The x coordinate comes first. And D is -4 and is up 1. Okay. Find the x and y intercepts of the equation. -2x minus 7y is equal to 42. So to find the x-intercept, you let y equal 0. So -2x minus 7 times y, which is 0, is equal to 42. So -2x is equal to 42. Divide both sides by -2. And x is equal to -21. So -21, 0 is your x-intercept. To find the y-intercept, you let x equal 0 and solve for y. So -2 times 0 minus 7y is equal to 42. -7y is equal to 42. This is 0. Divide both sides by -7, and y is equal to -7. Oh, sorry, -6. 7 times 6 is 42. I don't know what questions you have. Use the graph to identify the x and y intercepts on the graph. So the intercepts are where they cross the graph, here and here. So you have to look at how they are progressing these. So each of these lines looks like they're 2. So 6, 8, 10, 12, 14. If this line's 14 and this one's 16, that has to be 15. So the x-intercept is 15, 0. The y-intercept is going to be 0 something. And in this case, theirs is done by 2 as well. So -2, -4, -6, -8. It's not making it to the -10, so this is -9. Complex numbers. Express -5 square root of -36 as a complex number in A plus BI format. So -5, the square root of -36. 36 breaks down into the square root of 36 and the square root of -1. So that's -5 and then 6i. -5 times 6i is -30i. Now you could leave it in that format, or you could write 0 minus 3, 30i. I would accept either one of these. Okay. Next one, we're just adding. So you just add the like terms. First thing you do is get rid of your square roots if you can. So -18 plus, this is the square root of 64, which is 8, and the square root of -1, which is I. We're adding 25 minus the square root of 9 is 3, square root of -1 is I. Now we combine like terms. So we're going to combine the -18 and 25. And I don't think I have another Highlander available. Yes, I do. And we're going to combine the 8 and the -3i. All right. So -18 plus 25. I didn't even actually do this ahead of time. Give me just a second. -18 plus 25 is 7. And then 8 minus 3 is 5 plus 5i. And it's in A plus BI format, so I'm good. The next one, I'm going to go ahead and change these to 8i minus, leave parentheses, -25 plus 3i. All right. I'm going to distribute my negative. So 18 minus 8i plus 25 minus 3i. So combining the 18 and the 25, that's going to give us 43 minus 8 sorry, we have to subtract this. So 8, 9, 10, 11. So 11i. There we go. And it's in A plus BI format. Next one, perform the indicated operations and simplify it, expressed in terms of A plus BI. So we just need to multiply. Box, distribute, FOIL, pick your poison. I'm just going to FOIL real quick. 8 times 12 is 96, minus 8i plus 60i, and then minus 5i squared. Remember, I squared is also -1. So, and I'm going to combine these two like terms. So 96 plus 52i plus 5. So 96 plus 5 is 101. Yep, 101 plus 52i, and they are in A plus BI format. Find the product of -6 minus 8i and its conjugate. So the conjugate of the complex conjugate is -6 plus 8i. The only thing that changes is the sign in front of the imaginary number. Express the answer in terms of I. Sorry. All right. So -6 minus 8i. Product means multiply. So times -6 plus 8i. Just going to distribute real quick. -6 and -6 is 36. Outer is -48i plus 48i minus 64i squared. Remember, I squared is -1. So this is 36. These are gone. This is what happens when you multiply times a conjugate. And then plus 64 is 100. Evaluate the expression 2 minus 3i over 6i and write in. Okay, so we need to get rid of the I in the denominator. To do that, you just always multiply by the complex conjugate. Complex conjugate is -6i. And -6i over -6i is 1. So we're just multiplying the whole thing by 1. We're not changing anything. We're just rationalizing our denominator. So when you multiply, you have to distribute. -6i times 2 is -12i. And negative times negative is positive 18i squared over -36i squared. Remember, the I squareds are -1. So this becomes -12i minus 18 over negative times negative is positive 36. Now we need to write this in A plus BI format. So that's -18 over 36 minus 12 over 36i. And then we need to reduce. This is -1/3. Nope. 8 times 2 is 16. So that's -1/2. Sorry, y'all. That's -1/2 minus, there we go, 1/3 I. There we go. All right. -4 minus 2i over -1 minus 5i. And we want to multiply this by the complex conjugate of the denominator. All right, so we just need to distribute. -4 times -1 is 4. Outer, -20i, inner, plus 2i, last, -10i squared over +1, -5i plus 5i minus 25i squared. Remember, your I squareds are -1. So this is, just reduce the middle two terms here. 4 minus 18i plus 10 over 1, this is gone, plus 25 is 14 minus 18i over 26. But we need to create this into A plus the I format, so 14 over 26 minus 18 over 26i, and we can reduce these by 2. So 7/13 minus 9/13 I. Last one for complex numbers is I to the 73. So whatever that number is in the exponent, take it and divide it by 4, because I to the 4th is 1. So that's just the easiest one to get rid of it with. So 73 divided by 4, this is how I do it. I don't care about any number but the 18, because this number here needs to be 18 times 4. And I get 72. You subtract those and you get 1. Well, this is I to the 1, which is I. So I to the 73 is I. If this number was a 2, that would be I squared. And I squared is -1. If this was a remainder of 3, I to the 3rd is -I. And if this is a remainder of 0, those are the only options you'll have here. If it was a 0, anything to the 0 power is 1. Okay. Now let's go to 2-5. We're factoring and factor hell. All right, so 5m cubed minus 10m squared minus 15m is equal to 0. First thing I ask myself, no matter what the problem is what do they have in common? Because I can factor it out. They all have 5 in common, and they all have an m. When I factor 5m from 5m cubed, I'm left with m squared. 5m from 10m squared, I'm left with 2m. And then 5m from 15m is 3. I'm going to bring this 5m down, cannot divide it away, and I'm going to factor. All right, now once you get it factored, you need to set each of these terms equal to 0 and solve for m. Divide both sides by 5. M is equal to 0. Add 3 to both sides. M is equal to 3. Subtract 1 from both sides. M is equal to -1. You can solve this one however you want. You can solve it using difference of two squares. You can solve it with the square root property. It's totally your call. I'm going to do difference of two squares just because you're going to see square root property here in just a moment. So difference of two squares, it's the square root of the first, square root of the second, and then you just change the signs to have the difference of two squares. Remember, you cannot take the sum of two squares if it does not factor. So if we have p squared plus 144, it does not factor. Okay, that is prime. You could factor it by the square root property, but that's it. You can't factor it like this. It's not pretty. Add 12 to both sides. P is equal to 12. Subtract 12 from both sides. P is equal to -12. Now we have to use the square root property. First thing we have to do is move that 128 to the other side. Divide both sides by 4. 4 goes into 12 3 times. 4 goes into 8 twice. So I'm going to rewrite this up here. To take the square root of a, we have to take plus or minus the square root of 32. This factors into what? 16 and 2. So a is equal to plus or minus 4 square root of 2. Solve using the square root property. Again, this is going to give us a different answer. So 2j squared plus 64. Subtract 64 from both sides. Divide both sides by 2. negative 6, okay, 64 divided by 2 is 32. So we have j squared is equal to negative 32. Take the square root of both sides, plus or minus the square root of negative 32. J is equal to plus or minus, well, the square root of 32, we already know is square root of 16, square root of 2, but now we have the square root of negative 1. So it's 4i, the square root of 2. I wanted you to see that. Solve using completing the square. First thing I see is they're all divisible by 2. So I want to factor out 2. So this is dividing everything by 2. Leaves us x squared plus 4x plus 3 is equal to 0. All right, now, yes, you could have solved it the other way. I just saw that and I can just see that it needs to be done, or it can be done. How's that? First thing you do when you complete the squares, you have to move your constant to the other side. And put your blanks in. Take your 4, take your b, divide it by 2 and square it. So 4 divided by 2 is 2, 2 squared is 4. Add it to both sides. You can't add it to just one, you have to add it to both. Now let's create our binomial squared. Square root of the first, sine of the middle, square root of the last. Negative 3 plus 4 is 1. Okay, now we can take the square root property, square root of both sides. So x plus 2 is equal to plus or minus 1. Break this into 2. So this is x plus 2 is equal to 1, and x plus 2 is equal to negative 1. Solving for x, or subtracting 2 from both sides, we get x is equal to negative 1. And subtracting 2 from both sides, we get x is equal to negative 3. And those are your answers. Quadratic. You must solve using quadratic. Negative b plus or minus the square root of b squared minus 4ac. All of this is over 2a. First thing you need to do is move that 6 back over to the other side. Otherwise, this would not be correct. Your a is 9. Now, I could divide all these by 3. I kind of want to. It's not going to matter until you get to the end. You're going to have to reduce anyway. So let's just do this because I know you probably didn't do this either. B equals 12 and C equals 6. It would make smaller numbers, which is nice. Negative b plus or minus square root of b squared minus 4ac all over 2 times a. So 12 squared is 144. 9 times 4 is 36 times 6. 16 all over 18. So negative 216 plus 144 is negative 72. 72 breaks down into 9 and 8. Oh, let's do 8. Let's do something different. Let's do 36 and 2. Square root of 36, square root of 2, and square root of negative 1. So this is going to be x is equal to negative 12 plus or minus 6i square root of 2 over 18. Let's break these up. And now we can reduce. 6 goes into 12 twice. 6 goes into 18 3 times, plus or minus. So if 6 goes into 6 once, so that's just I squared root of 2 over 3. And it's an a plus bi form. All right, that takes care of your factoring. Let's go to other types of equations. Got some absolute values here. All right, so we're just solving for x. We're going to add 5 to both sides. 7 absolute value of 6x minus 6 is equal to negative 21, right? And then we divide both sides by 7. Absolute value of 6x minus 6 is equal to negative 3. Well, you can't have an absolute value equal to a negative. That's not going to work. You can't, it does not exist. B and E, whatever you want to write. So you're done. The next one I gave you because I wanted you to see what you do if it's not negative. So we're going to add 5 to both sides. Is 49. Divide both sides by 7. All right, now, this is what you do if it's the absolute value is equal to a positive number. You have to break this into two pieces. 6x minus 6 is equal to 7, and 6x minus 6 is equal to negative 7. Okay? Solve for x. Six add 6. 6x is equal to negative 1. Divide by 6. X is equal to negative 1. Square root. Well, when we have a square root on one side, to get rid of it, we need to square both sides. Please do not do this as x squared plus 13 squared. That is wrong. It is a binomial squared, which is x plus 13 times x plus 13. You have to multiply it, FOIL it, distribute it, Cox method, pick your poison. So this turns out being x plus 145 is equal to x squared plus 26x plus 169. All right, subtracting, oh no, I have to subtract everything. Subtract x, subtract 145. I need to set this equal to 0. Subtract x, subtract 145. So 0 is equal to x squared plus 25x plus 24. What I see. All right, factor. Uh, 24 and 1 will give me 25. Done. 24 times 1 is 24. Check my OI. I got 24x and 1x. That's 25x. Sweet. Set each of these equal to 0. Solve for x. We need to check these. We've got a square root here. We need to check them. So does it equal? I always say this whenever you have a square root to deal with. So I'm going to plug these back in. Does the square root of negative 24 plus 145 equal negative 24 plus 13? 145 minus 24 squared 121 is 11. And this is going to give me a negative number. We can't have a square root equaling a negative number. This doesn't work. Let's check the other one. Stop it. This is the square root of 144, which is 12. 13 minus 1 is 12. So that one works. So our answer is x is equal to negative 1. Be careful with that, y'all. Solve. Don't care how you solve. You can let u equal t squared. I'm just going to go ahead and factor. I find that students don't usually struggle with factoring to the fourth. Now, I'm not going to choose 12 and 12 because that's not going to give me 25. Neither will 144 and 1. So let's take 144 divided by, I don't know, 12 times, what do we want to do here? Let's do 4 to see what it is. 36 and 4. Nope, that doesn't work. So it needs to be in between 36 and 4. Let's try 6. 6 and 24. Nope. Let's try 8. 8 and 18. I don't think that works either. No, because that gives me 26. So is there just 144 divided by 9 and 16? That's it, 9 and 16. 9 and 16 will give me, check my OI, will give me 25. -9, -16, -25. All right. So now we can do this in two different ways. You could do the difference of two squares, or you could do set them equal to square root property. I'm just going to go ahead and factor them all. They're all the difference of two squares. And set them equal to 0. Square root property will give you the same answer. All right, add 3 to both sides. T is equal to 3. Subtract 3 from both sides. T is equal to -3. Add 4 to both sides. T is equal to 4. Subtract 4 from both sides. T is equal to -4. All right, I might stop after this one just to create a different video. All right, I'm going to let u equal 4x plus 5. UA, pick a letter. So u squared plus 3u plus 2 is equal to 0. Check your OI. Yep, it works. So u plus 2 equal to 0, u plus 1 equal to 0. I can go ahead and solve for u. I'm just going to go ahead and plug in my 4x plus 5 plus 2 equal to 0. 4x plus 5 plus 1 is equal to 0. And solve for x. So this is 4x plus 7. Subtract 7. Divide by 4. So x is equal to -7/4. This is 4x plus 6. Subtract 6. Divide by 4. And x is equal to -3/2. Please reduce. Oh, it's 2.7. It's the last. How much is there? But I'm going to make another video.